Okay, let's do this question. It says, in this circuit, V1 equals 12 volts. Find Vs. So where's Vs in this particular circuit? Well, we know Vs is going to be the voltage at this source right here. Alright, now we know V1 is what they gave us, and V1 is going to be the voltage across this 4K resistor right here. So we know this voltage is 12 volts. Now, what is the first thing we should do when approaching this problem? Well, there are multiple things we can do right away. Now, the first thing I always like to do is if I can simplify a circuit by combining resistors, that's what I always start with. Right away, I can see I can combine these two resistors because these two resistors are going to be in series. And to combine these two resistors that are in series, we know we're just going to add them. So we're going to have 1 plus 3, and that's going to equal 4 kilo ohm. So let's redraw this circuit quickly. Okay, now that we have this, we know we can still write back the voltage V1 across this resistor because we did not do anything to this 4K resistor. And we know we're going to have this voltage source Vs. Now right away, we should be able to see that we have these two resistors that are going to be in parallel, so we can just combine those resistors. So we have 4 multiplied by 4 over 4 plus 4. When you simplify that, that's going to give you 2 kilo ohm. So let's redraw this circuit and replace these two resistors that are in parallel with a single resistor with a value of 2 kilo ohm. Now let's look at this, right? Instead of writing V1, I actually want to write the value of V1. Now what is the value of the voltage across this 4K resistor? Well, we know the value of that voltage is going to be 12 volts according to our question. So instead of writing V1, I'm actually just going to write 12 volts. Okay. We know they want us to find the value of this voltage source Vs, right? Which is this voltage right here. Now when we look at this, we know there's going to be a current that's going to leave this voltage source and it's going to come this way. Let's label this current I sub 0, right? Now once this current reaches this node right here, this current is now going to split. It's going to go in this direction. I'm going to label this one I1. And some of the current is actually going to travel in this direction. I'm going to label this current I2. So I sub 0 is going to come into this node and split. And it has two different paths. It can go this way or this way. We should find the current I2 that's going to be flowing to this 4K and 2K resistor, right? The way we can find the current I2 is we know the value of the voltage across this resistor, which is 12 volts, and we know the value of this resistor, which is 4K. Therefore, the current traveling through this resistor can be found using Ohm's law. So we can say I2 equals voltage over resistance. The voltage in this case is going to be 12 volts. And we know the current is entering the positive terminal, so it's going to be a positive current, over the value of this resistor is 4K. Just going to write 4,000. Therefore, the current in this particular resistor is going to be 3 milliamps. So the current I2 is going to be 3 milliamps. Now this isn't what the question wanted us to find, but it might be helpful to us, so we're just going to circle it. So we know this current I2 is going to be 3 milliamps, and this current is going to flow through this 4K resistor and this 2K resistor. Now when we look at this, we know something, right? We know that these two resistors are going to be in series, and if we was to combine these two resistors, these resistors are going to be in parallel with this 6K resistor. So let's do that. The first thing we're going to do is combine these two resistors. We know 4K plus 2K is going to give us 6K. Now we know this 12 volt voltage is no longer going to be there because once we combine these two resistors, this voltage cannot be rewritten because this 12 volt voltage is just for this 4K resistor. not the entire 6K. Now what we could redraw in this circuit is going to be the current I2, because we know that current I2 is going to be the same across this 4K resistor and this 2K resistor. We can also rewrite this current I1, and we can rewrite this current I sub 0. Now we know the current I2 is 3 milliamp. So what I'll do in this particular situation is, because I want to find the voltage Vs, all I'm going to do is I'm going to use current division to find the value of I sub 0. Now we know we can use current division because we don't know the source current, but we know we have two resistors in parallel. And we know the value of the current for one of these resistors, right? All we have to do is use current division to find the source current by just manipulating that equation. So what we're going to do now is we're just going to write out the formula for current division. We know the equation for current division is going to be I1 equals IS multiplied by, we're going to have the second resistor over the sum of both resistors, and that's going to give us the current I1. Now, we actually know the current I2, so I'm just going to manipulate this equation to write for the current I2. So to find the current I2 using current division, instead of I1, I'm actually going to write it as I2 equals I source. But instead of writing IS, I'm actually going to write I0 because that's what I labeled my source current as. I'm going to write I0 multiplied by, because we want to find the current in the second resistor, I'm actually going to use the first resistor for our numerator. So R1 over the sum of R1 plus R2. Okay, let's plug in values. We know I2 is going to be 3 milliamps. That's what we found. So we have 3 times 10 to the minus 3 equals I sub 0, which is the source current, which is the current flowing through this source right here, multiplied by, we have R1, which is going to be the 6K, so we have 6,000, over R1 is 6,000, and R2 is also 6,000, so we have plus 6,000. Now let's start to simplify this. When we simplify this, we're going to get 3 times 10 to the minus 3 equals I sub 0 multiplied by, we're going to get 1 over 2. Therefore, we can say the current I0 equals 6 milliamps. Now once again, this is not our answer, but this might be very helpful to us later on. So we're just going to circle it, right? Now we know the current I sub 0 in this circuit, which is going to be the current flowing through this voltage source here. Okay, now when we look at this, there are so many things we can do at this point, right? We can find the current I1 and take KVL at this loop. We can combine these two resistors, right? Once we combine these two resistors, we'll be able to find the voltage through each one of those resistors, and that's going to give us the sum of this voltage source right here. Another thing is we can use KVL at the outer loop to find the voltage Vs, because we know the current flowing through this resistor and we know the current flowing through this resistor. So there are multiple ways you can go about this, right? You don't have to go in one particular way. Also, you can say, all right, if you know the voltage across this 2K resistor, you can combine these two resistors and you can use voltage division to find what is the value of Vs. You know what? I'm going to go that way, right? I want us to practice with voltage division, so let's do it that way. But as you can see, there are so many ways you can go about solving these problems. So we have these two 6Ks in parallel. If we was to find the equivalent resistance, that's going to give us 3K. So I'm just going to redraw this circuit very quickly. And we know the current IO is still going to be flowing through this circuit here. We know we can find the voltage across this 2K resistor. So what's going to be the value across this 2K resistor? I'm actually just going to label it V1. Or let me label it VA. I'm going to label this VA. And the voltage across this 2K resistor is going to be VA equals IR. We know the current is going to be I sub 0 multiplied by the resistance, which is 2000. VA equals the current I sub 0 equals 6 milliamps. So we have 6 times 10 to the minus 3 multiplied by 2000. Therefore, VA equals 12 volts. So that's the answer for the voltage across that 2K resistor. Now we can use voltage division to find the voltage source because we have two resistors in series and we know the value of one of those voltages across one of those resistors. So all we have to do now is write out the formula for voltage division, right? I'm going to say VA equals VS multiplied by RA over RA plus RB. Of course, you can write V1, RA, it doesn't really matter, right? You can kind of change the equation up to suit whatever you're dealing with. Now we know VA equals 12 volts, so I'm just going to write in 12 volts. We have 12 equals VS multiplied by RA is going to be 2000 over RA, which is 2000 plus 3000. When you simplify this, 12 equals VS multiplied by 2 over 5. Therefore, the value of VS equals 12 multiplied by 5 over 2. When you put this in your calculator, VS equals 30 volts. So this is the answer to this question. The voltage source Vs equals 30 volts. So we've successfully solved this problem. There are multiple ways you could have went through this particular problem. I just decided to show you the current division and voltage division method just for practice, right? So the first thing we did is we combined these resistors, right? They were in series. We combined those two resistors. Once we combined those two resistors, we knew that we had two more resistors that we can combine, and this time these two resistors were actually in parallel. So we combined those two resistors. Once we combined those two resistors, we knew the value of the voltage across the 4K resistor right here. So all we did is instead of writing V1, we actually wrote in the value of V1, which was 12 volts. We knew that there's going to be a current leaving this source and it's going to split at this node. So we could have found the value of I2 because we know the voltage across this resistor and we know the value of this resistor, and that's going to be 4K. And we know once we find the current in this resistor, that's going to be the same current in this resistor because these resistors are in series, which means they have the same current flowing through them. So once we found that out, we found this current to be 3 milliamps. So then what we decided to do was we said, you know what? We have these two resistors in series. Let's just add them. So we said 4 plus 2, that gave us 6. We knew the current I2, which was 3 milliamps. And we noticed we had these two resistors in parallel. So we thought to ourselves, what can we do next? Now there are many things we could have done at this point. But because we can recognize we have two resistors in parallel, and we know the current flowing through one of those resistors, we can easily find the source current by just using current division. So we used current division and found the source current is going to equal 6 milliamps. So once we have the source current 6 milliamps, then this made our lives a little easier, right? At this point, we were able to do so many different things. Now all I did was I decided to combine these resistors because I know I can find the voltage across this 2K resistor. So I wanted to just have one loop, right? So I wanted to have these particular resistors in series. Now once I found the voltage across this 2K resistor, because these two resistors were in series, and I knew the voltage across one of those resistors, I knew at this point I can use voltage division. Yes, I don't know the voltage source, but I knew one of the voltages across one of those resistors. So I was able to manipulate the equation in a way to find the voltage source, and when I found Vs, that gave us the answer of 30 volts. I'm going to wrap up this video by saying there are multiple ways to solve these problems. Whichever way you're comfortable with, go ahead and solve these problems that way. The purpose of this video is to show you how to become proficient and how to be able to recognize when you can use current and voltage division when analyzing circuit problems.